Assalamualaikum warahmatullahi wabarakatuh. So this is the second portion, second part of chapter 17, inshallah. So we will cover up to the bits, the last parts. So let us recall what we have seen in part 1. Identify the note and whereby the positioning is for notes is kx, where equivalent to pi, 2 pi, 3 pi, okay, where anti-notes kx itself is a product of pi over 2, half of it, and therefore the x should be lambda over 4. So for notes, it's lambda over 2, okay, onwards. So divided with 4 for anti-notes, notes is half of it, right? And product of the anti-notes, product of amplitudes itself is 2a. Yes, anti-notes itself is 2a sine kx. So again, look again in the form of concept. Distance between anti-notes is half of the lambda, including nodes to nodes is also half of the lambda. However, anti-nodes and nodes next to one another, we call it adjacent, is 1/4 of the lambda. Alright, this would be new parts of the parts 2, where boundary effect. So this is a case where wave can be reflected, and we're going to see what will be the product of reflections. So over here, we have two types of reflection. One reflection whereby the end parts, one part left, the end part is fixed end. We call it as fixed end. Fixed end, yeah, fixed end. The other parts is on figure 17.10 is free end, okay, free end. So when things reflected, similar as what we observe our figure, our image inside a mirror, the left become right, right become left, okay. However, our body does not turn upside down lah. But in the case of an incident pulse or wave over here, that originally is upright, after it gets reflected, it gets inverted in opposite direction. Whereas incident, in the case of free end, okay, because there is no nothing to reflect it back, because it's possible to move around. At the end here, it's a free, okay. So you're going to see that the reflected wave will travel in the same direction as well. Right, these two concepts will be the build-up concept for later bigger picture. Right, here we have two figures that try to show how wave travel and then has the ability to partially reflected and partially transmitted. Okay, so partially reflected. Okay, have a look. We have pulse over here traveling on a thin string, but afterwards it encountered a bigger density string. So what happened is, because the other portions over here is larger in shapes and in size, so we find partial of the original gets reflected. So that's the reason why the amplitude is slightly less than the original, but half of it means penetrate and passing through. On the side notes here, when it continue and then meet ups with another we call less heavier, lighter string, we find that it does not bounce back in the form of inverted, okay, in the form of inverted, because this is this is a case where it resembles the free end reflections. So it doesn't get reflected, but half of it gets passing through. Now let's incorporate the idea that if we have a fixed end earlier, the wave would be reflected in the opposite direction under the concept of the standing wave earlier. So what we have over here is a string that bounds fixed at both ends. So what happened when the wave or the pulse travel, by the time it reached the other end, fixed end, it get bounced back in the opposite direction. So that is the reason why wave on a string, standing wave on a string, look as such that on the where ends are located, fixed end are located, there will be notes, symbols there. So we have this harmonic called as, this is fundamental of first harmonic. The terms harmonic here is referred to the end. But 1, 2, 3, 4, 1, okay, the n number, the series here, this is called as harmonic series. So this is second harmonic, this is third harmonic. What's the difference? First, gonna get one segment, two segment, three segment. Okay. Right, where is the nth note? N notes, dia nak tahu juga. So nth notes is at the maximum. Notes is at where amplitude is 0. Okay, well done. So basically, if they start asking you in this particular figure, what is the wavelength? So you can see here, a wavelength should consist something like this. The whole length is one wavelength. So for this picture, it's half of the wavelength. So to get the wavelength, therefore, it should be 2L for this picture, where it's fundamental of the first harmonic, fundamental or the first harmonic. So what is the wavelength? Get 2L, dua kali, and then divide by N dia 1. So idea dia adalah wavelength dia sama juga dengan 2L sahaja for this picture. How about this picture? Okay, according to this equation, 2L dia 2 kali ganda, ambil length dia 2 kali ganda, and then divide by 2. So you're gonna get L juga. So dia punya wavelength adalah 2 L sahaja. L sahaja for this picture. So this as such. So this equation is correlated with this one. Now accordingly, it's the same as this one. But if you are observant enough, you would notice that one wavelength is from here until here. So basically the whole length need to be divided with 3 and then times 2. Okay. Now to recap and to combine with lambda earlier, so we have to put it into expression VF lambda, and then the lambda that comes from the previous slide we substitute over here, and we have a new expression V over lambda becomes NV over 2L. So this expression is very important because they're gonna ask you what is the resonant frequency for the third harmonic, fourth harmonic, fifth harmonic, or the fundamental harmonic. So how to solve it? Use this expression. Okay. So basically the N1, 2, 3 ini, these are all numbers meant for what we call as series. Siri 1, siri 2, siri 3, siri 4. Tapi kalau dia nak number harmonic, we call first harmonic ataupun fundamental harmonic, second harmonic, third harmonic. Okay. Now, there are another names, tapi another names tu nanti kita panggil dekat kelas lah. Ya. Nanti kita ajar dekat kelas. Alright, the writing style, you would notice bahawa kalau dia punya F1, maka contohnya sama juga dengan 30. F2, according to this expression, number 2 dia akan jadi 60. Number 3 ni 90 because it's increased by the integer of 1, 2, 3, 4, 5. Okay, a factor of 1, 2, 3, 4, 5. Darab je lah. Kalau dapat N1 sama juga F1 adalah sama dengan 50. Jadi kalau 50 kali 5. Maksud kali 5 tu adalah akan dapat the fifth harmonic. Okay. Alright. With NV over 2L, meaning to say, tadi dia ulang balik the lowest frequency means that fundamental is F1 and 1. Okay. So, jadi kalau masukkan rumus NV over 2L, ini actually disengaja nak tunjukkan bahawa that the V can be rewrite again into square root tension over mu. Macam dah jumpa kan expression ni? Dah. Tadi masa dekat string. Alright, so now let us have a look on how to solve this question, which involve standing wave on a string. Okay, so the string that we are looking at is in the piano itself. So the body of the piano, yes, we do put our fingers as such to create the sound, but if we open the body of the piano, we find there are multiple string of wires. So not only piano, we also have guitar or anything that use of musician instruments that make use of string. Then you should observe that this object or this device is actually operating using concept of standing wave. So what does it says here? It says here that the middle C string on a piano, it has a fundamental frequency of 262. And then another string, okay, and the string for the first A above middle C, another string lah, it has a fundamental frequency of 440. Alright, so focus on C string, which is 262. They want the frequency of the next two harmonic, meaning to say F1, F2, F3. So F1 tadi 262, kalau 262 times 2, dapat 524. Number 3, 262 times 3, dapat 786 Hz. Macam tu. So, multiply kan by the integer of the next two. 1, jadi next two dia 2, 3. Okay. So, now focus on okay, now we have another question. So it says here, if A and C, they have the same linear mass density, which would be mu, and as well have the same length. So you have to determine the ratio of the tension in the string. Alright, this question was trying to say behind the story lah, that between A and C, the reason that they have different value in the fundamental frequency is due to tension value itself. Ketegangan tali mereka berbeza. So what we did is the two expression gonna be divided themselves. So this expression for F1 A, this expression for C. Right, so divide themselves, you would notice that mu to L would be dismissed. Kita boleh cancel out. So as we cancel out with frequency frequency A over frequency C, so kita akan leave out only tension A over tension C square root. Jadi substitutes the tension. If you ask me again, why kita cancel everything, madam? Sebab the original dia punya idea, dia dah kata linear mass density and also length have the same value. Okay, so with that, as we simplify and solve, we're going to get the ratio of TA over TC is equivalent to the fundamental frequency A over C but square product. So you're going to get 2.82. So that's how you respond to the question. Macam mana nak jawab soalan tu according to the given scenario. Now the earlier portion is regarding about standing wave, where make use of wave on a string. So now we look at the bigger picture, that standing wave is a part of a bigger phenomena which called as resonance. So what is resonance? Resonance is where the amplitudes of the resultant would be the greatest. When during this time, what happened is the frequency of the applied force. What it meant by frequency of the applied force, just now the string is vibrated due to this device yang kotak ni. Okay, vibrating blades ni. So frequency of this device is equal to the natural frequency of this string itself. So this string dia ada frequency dia sendiri. If alat ini vibrate similar as the natural frequency of the string, then only you akan observe standing wave. Then only you akan observe resonance. Right? So example, let's say that frequency resonance dia untuk number 1 adalah 60. Jadi kalau alat ni vibrate at 60, baru nampak the phenomena of the standing wave. Kalau tak boleh nampak. Macam tu. Right, let's have a look at another example of standing wave, but however we are making use of air punya situation. So earlier standing wave on a string, okay, physical, and then now it's in the air. So scenario that we are going to see is is open at both end. When it's open at both end, recall back when light traveling of gelombang wave meet up with a fixed end, that it bounce back in opposite direction kan. However, because this is free end, maka the wave cannot be bounced back in the opposite direction and resulting nodes. So therefore, it will be a product of antinodes at the open ends. Antinodes, 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 antinodes. So both ends akan produce antinodes. However, the shape would be as such, and you are expected to remember bentuk separuh cup, and then bila dia gabung balik dapat satu segment. One segment is equivalent to the similar figure you seen earlier dalam previous slide, which meant for standing wave on a string. Okay, so the next one for the second harmonics, so at the free ends you're going to see antinodes, and from there you work out, you must ensure ada dua segmen, satu segmen half and then half, add them up. Kalau di third harmonics maka ada tiga segmen lah, 1, 2 and then half. Okay, now since the product of the lambda itself, the lambda is measured from here sub. From here it becoming an inverted cups. Maknanya missing another half kan. Jadi kalau kita nak dapatkan lambda dia mesti 2 kali of this length to here. So that's why lambda dia 2L. So you find that repetitive of these three expression, dia very similar back to what we seen dalam bentuk string. So eventually the natural frequency or harmonic series for spring, rumus dia ada rumus yang sama as string. Tu je ingat, rumus dia sama saja, NV over 2L, and V is square root, tak boleh pakai tension over mu. Tension over mu tak boleh pakai kat sini. Yang ni V dia adalah speed of sound. Okay. Alright, this is a situation of a column where it is closed at one end. Okay, by right, you should start asking apa a column ni. A column ni, I give you an example. Flute. Seruling. Seruling. Okay. Seruling, kalau dia, seruling, kalau ini seruling. Kita tengok kat tepi kan. Macam tu kan. So, this is considered as open at both end. Tapi kalau kita tiup macam ni, ni kita panggil close at one end. Dekat mulut kita tu is actually close. Anyway, coming back to this figure, so you would have noticed that the fixed end, sebiji macam string tadi, akan exist nodes positioning. Nodes punya rupa ya. And then at the opening ni adalah antinodes. Alright. On the right side ni apa? On the right side ni adalah how the air particle and pressure varied. So, in the case of over here, during antinodes occurred, the pressure is very less. Okay. So that's why in terms of the figure ni, rupa dia nampak macam cair sedikit ya, lighter in colour. So pressure dia less. And then yet dia punya sebutan tu lain sikit. Antinodes and anodes. So yang ni kita jarang fokus lah. Usually it was this figure which is play much bigger role. Okay, eventually they will ask you how to sketch. So please know how to sketch bentuk macam ni. So these shapes is actually 1/4 sahaja daripada one wavelength. Okay, 1/4 daripada wavelength. So F sama juga V over lambda. So lambda dia adalah perlu 4 kali ganda daripada panjang ni. Ni 1/4 je baru wavelength. So 4 kali. So that's why V over 4L. Kalau bentuk yang kita sedang tengok ni, ini mewakili bahawa lambda dia adalah 4/3. Kita bahagikan kepada 3 side and then kita darabkan 4. Okay, then only baru kita satisfied with equivalent to a lambda. Sebab a lambda dia from here ada missing another quarter over here kan. Okay. So that's why kita darab 4, tapi kita kena bagi dahulu. Dapatkan per segmen ni berapa. Right. So from there kita deduce that frekuensi ketika ini adalah 3V over 4L. And then fifth harmonic. Kenapa fifth? So 1/4, 2/4, 3, 4, 5. Okay. So idea dia macam ni. The expression itself lain sedikit, differ sedikit daripada over 2L dalam bentuk dia close pada satu portion. Tengok bila dia fix tali, fix at both end atau dia open at both end for air column, diorang dua-dua ada rumus yang sama, NV over 2L. Tapi kalau the moment one close, then the rumus weird sikit. The rumus turns out to be MV over 4L. You can choose to be N pun tak ada masalah. This is just harmonic series saja. We just don't want to use the same symbol so that we don't get confused with the previous expression. So eventually, for you to digest, to know that dia punya susunan akan jadi series dia tidak jadi 1, 2, 3, 4 but instead exist dalam odd numbers. 1, 3, 5, 7, 9 and onwards, yeah. And V over 4L. And again, don't put V as tension over mu. Salah, ya. Speed of sound. So ulang balik, the harmonic series is odd integral numbers. Okay, odd integral multiples. Now these two exercise, I'm gonna leave this as homework for you, yeah. So do try it out. Let's see the outcomes. Alright, example 17.5. Wind in a culvert. What is a culvert? Culvert ni yang selalu kita buat penguat kepada laluan air so that kita boleh buat bridge, ya, bridge ataupun memang untuk water column lah, water column. But basically, when it is left as such on the flat ground, so a section of drainage culvert 1.23 meter in length makes a howling noise when the wind blow through across its open end. So ini case buka dua-dua, both end. Now you have to determine frequency of the first harmonic F1, F2, F3. If it's cylindrical in shape and open at both ends and speed of sound is 343. So expression V over 2L tu masukkan je V dia 343 and then length dia masukkan 1.23. That's it. Kalau untuk nombor 2, 139 darab 2. Nombor 3, 139 times 3. Right, that's it. All it takes. Alright, example 17.6 is a scenario where close at one end. So the upper part kat sini buka and then at where the water level is, dia close. So it's close end. So bila dia close end, recall balik, kalau fundamental frequency dia mesti divided by 4L. Kalau open 2L. Ni close to 4L. Alright, so what is the story? Dia kata a simple apparatus demonstrating resonance in air column depicted as in figure. A vertical pipe open both ends is partially submerged in water to produce one end close end. And a tuning fork as a source of sound or force vibration, force frequency, vibrates at an unknown frequency. We don't know the frequency. Placed near the top of the pipes. Now, the length of the air column can be adjusted by moving the pipe itself up and down. So with that, we have different air column punya length. So the question, the length of, So the sound wave generated by the fork are reinforced. When reinforced makin kuat lah. Reinforced here resonates lah. Itu dia. Vibration dia maximum. When L correspond to one of the resonant frequency of the pipe. So it was explanation lah. Maknanya even though we do the variation of height, somehow kalau kita punya height tu proper, similar as the resonant for case here, macam ni, then kita akan hear sound, ya. Sound tu lah yang kita panggil sebagai resonance. So for certain pipe, the smallest value of L for which a peak occurs is 9. Dia kata kalau gambar ni 9 cm. So dia kata kalau lah the first one 9, what will be the frequency dia? That's what the question is all about. So what would be the frequency of that fundamental since L is given tadi, dia kata 0.09 during this time, 9 cm ni, first fundamental resonance heard of, kan? Jadi substitute accordingly and then remember 343 ni adalah speed of sound in air. Okay, so we arrive with this answer. So that's it. Okay. Macam mana nak tahu V over 4L ni? Sistem tu adalah satu mesti tertutup hujung dia. Close at one end. Right, next question. What will be the value of L itself for the next two resonant condition? Okay, so kita dah ada expression dah bahawa masa L number 3, macam mana lambda dia berapa. L number 5, lambda dia berapa. Okay, so rujuk balik that expression in the given figure earlier. Okay, to substitute 3 lambda over 4, maknanya kita perlukan lambda. So how do we get the lambda? Kita boleh go with the generic expression V sama F lambda pun tak ada masalah. So V F lambda, dapatkan lambda dia dapat arrive with 0.36 kan. So 0.36 ni substitute balik darab 3, bagi 4, you're gonna get it. Ulang balik, tapi yang the next one kena ingat, dia tak exist dalam integer 1, 2, 3. Dia exist dalam 1, 3, 5, 7. Jadi the next one jadi 5. Kalau lagi satu lagi 7. Okay. Okay, give it a try. Alright, this is the last subtopic. Idea dia adalah beats. What is beats? Beats is variation, is the periodic variation in amplitudes at a given point due to the superposition of two waves having slightly different frequency. Maksudnya ada dua wave, frekuensi tu katalah 50 dengan 52. Kalau dua-dua ni meet up, jumpa, nanti you akan dengar slightly larger bunyi yang kuat. Tak, 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 tak. Macam tu. So, nanti saya minta you go back to this video, look at what is the output so that to understand much better lah what it meant by the beat over here, yeah. Now that slightly differ frequency just now, okay. So kita boleh nampak two different wave over here, tapi dia punya frequency lari sikit saja. And then when they overlap with one another, we find that the positioning here we have amplitudes, positioning over here we have notes, amplitudes, notes, amplitudes, ataupun kita panggil anti-notes. So as if you dapat balik standing wave, macam dapat standing balik, tapi in a version where during that time you akan dengar that sounds prominent, kuat sikit daripada bunyi keadaan dia. Okay. Usually we use this concept bila kita nak tune kan kita punya gitar. Kita tahu bahawa kita main gitar, tapi after sometimes the tension atau ketegangan tali gitar tu akan berubah. Bila ketegangan dia berubah, maknanya dia punya nilai frekuensi tu dah berubah. We don't want that because bila kita main piano ke main apa-apa, we want it of some value of C yang kita tahulah. Bunyi C bunyinya tinggi macam ni, for example. Jadi what we did adalah kita ambil satu alat, kebiasaannya kita ambil tuning fork, okay? Atau nowadays very modern, kita just cari je frekuensi tu dekat YouTube. Then kita mainkan next kepada kita punya alat yang kita nak tunekan tu. Semula retune. Retune ni kita panggil calibration lah. And then the very moment you dengar beats tu means that frekuensi antara kedua-dua kita punya alat dengan kita punya standard tu hampir sama. Sampai beats tu hilang, then we can say that, oh, now I punya frekuensi dah back pada asal. Itu function yang selalu kita panggil dalam dunia muzik lah, kegunaan beats. Right, so calculate what is the beats. Beats is differences between the two frequency, differences. F diorang tolak satu sama lain. F diorang tolak satu sama lain. Okay, looking at this example 17.7, so dia dah sebut dah mistune. So dia nak tunekan balik, nak recalibrate, nak calibratekan balik piano string dia. Two identical piano string of length 0.75 are each tuned exactly to 4/4. Oh, tension in one of the string is then increased by 1%. Dah tukar tension, maknanya dia punya frekuensi, resonance frekuensi dia tidak sama. So if they are now struck, what will be beat frequency between the fundamental? Beat required kita tolak the two frequency. Kita dah ada 4/4, tapi the other one which we have increased to 1% tu kita tak ada frekuensi dia. Jadi tugas kita kena cari frekuensi dia. Now, all methods adalah dengan menggunakan 4/4, 0.75, kita cari mu dahulu. Bila cari mu, nanti masuk balik dalam expression NV over 2L ataupun V over N tension over mu square root. Okay. So, dan kita cari apakah nilai F dia yang baru apabila kita tinggikan tension tu sebanyak 1%. So, kalau 1% ni kita akan tulis sebagai 1.01. 1.01. Okay, 1%. Sebab 1/100. Jadi, kalau 100/100, maknanya 1 je lah. Increasing by 1% ni bermaksud 1/100. Okay. Tambah balik 1. Ataupun 100 campur 1, 101. 101 bahagi 100. Dapat 1.01. Alright, so methods used by the textbook, dia guna konsep ratio, rumus bagi rumus, and then dia ambil yang baru divide by yang lama. So difference dia adalah mu dia orang sama, jadi we can cancel out mu dia. Jadi leaving only tension over tension kan. Tapi tension yang baru ni, T2 ni akan jadi sama juga dengan T1 sebanyak multiplying by 101%, 101 over 100. Jadi dapat 1.01. So bila kita potong T1 and then leaving our answer as square root 1.01, solving dia akan dapat 1.005. Jadi frekuensi baru kita akan 1.005 ni darab dengan frekuensi 440. So new answer kita akan dapat 442. So 442 dengan yang asal tadi 440, dia orang punya bits adalah differences between them. So that's how we arrive with 2 Hz. Alright. For the next task, I need you to go to the MCQ questions, attempt them. Thank you. That's the end of part 2 of chapter 17. Thank you again.